Hello everyone, welcome you all on our online lecture series on element of machine design subject. In last lecture we have discussed design procedure and introduction about design of key and different types of key, and in this lecture we are going to discuss one numerical on shrunk key, and the statement for that is design a rectangular key to be used for shaft of a diameter 50 mm. Both are having same material, that is key and shaft. Take shear stress is 42 megapascal and crushing stress is 70 megapascal. Now write given data and what we have to find. First of all, in such problems we have to determine width of key, thickness of key and length of key, and these three quantity are we have to find these three quantities, and what we have in a given first quantity, that is diameter, d is equal to 50 mm. Then the second quantity is shear stress. Shear stress max, that is allowable condition, is 42 MPa, that is Newton per mm square, and I will write here unit same given on problem. And the third quantity, that is crushing stresses, sigma c is equal to 70 MPa. Now use both the condition, that is direct shear stress condition and crushing shear stress condition, which we have studied in last lecture. You can find that video in by clicking here. Now we will move towards our first step, that is consideration of key or design of key by direct shear stress condition, and the formula for that is T is equal to W into L into tau D, that is shear stress, into R. Instead of R you can use D by 2 also. And what is D? D is equal to 50 and R is equal to 25 mm, and you have to put here. Now before of that we don't know torque, so first step is to determine value of torque. Now I will write here the formula for torque is equal to pi by 16 into tau s into d cube. Okay, this is the basic formula for determining the torque value. You can find this derivation in our previous lecture also. Now put the value in calci, this is pi by 16, use a bracket properly, tau, that is shear stress, and we have that value 42 into 50 cube. Okay, find the value of torque. We have both the quantity in same unit, that is mm, so we will get value of torque in Newton mm, that is 1030.83 into 10 raised to 83 into 10 to the power 3, and the unit of torque is Newton mm. This is our first quantity. Now put the value of torque in this equation, that is the equation of direct shear stress condition for designing the shaft. Now I will write here quantity. Here I will write the equation T is equal to W into L into tau D into R. Put the value of torque. T is equal to 1030.83 into 10 to the power 3 is equal to W, because we don't know that the width of key, unknown again length of key, then tau of D, that is shear stress, we know that the value of shear stress 42 mm, it is given in problem, and radius, because we have the diameter 50 mm and the half of diameter is a radius. but we don't have two quantity, that is width and length, but we have one parameters or one step in equation that the key is a rectangular one, and we know that when the key is a rectangular one, at that time the thickness and width are having some proportions, and what they are: thickness is equal to 2 times of width divided by 3, and we have studied it in lecture number first of key section, and you can find this lecture here in description. Now we have the value of t now, but in equation we don't need the value of thickness, we only need the value of w and l. So check that proportional value, that is value of t is d by 6, because width is equal to d by 4, that we have studied in last lecture. Now here we will get thickness is equal to d by 6, and we know that the value of d now. Now put the value of d in this equation, and we will get as 50 by 6, and the 50 by 6 is equal to 8.33, and the value of t is equal to 8.33. okay, mm. This is the first quantity, that is thickness of key section by using empirical relation, and the empirical relation for thickness is d by 6. okay, remember this quantity for design of key. Now we cannot put the value of t in equation of direct shear stress. Which one? This equation. So we will use the equation crushing condition or crushing stress equation, and the equation is t is equal to L into t by 2 into sigma c, that is crushing stress, multiply by r, that is radius. We know that value of torque is 1030.83 into 10 to the power 3 is equal to, we don't know the length, so as it is, and t is equal to 8.33 divided by 2 multiply by sigma c, that is 70, and r 25, that is half of diameter, and the diameter is 50 mm. okay, now the unknown quantity here is only length. Now solve this equation and divide this portion to the value of torque, and we will get value of length, which is equal to 141.42 mm. Use bracket properly, and the unit of length is mm. So write the second value, L is equal to 141.42 mm. Now this is second value of key, and at the last we will use previous equation, that is direct shear equation, and which is nothing but t is equal to w into L into tau into r. okay, put the value of t 1030.83 into 10 to the power 3, that is value of torque, w as it is, length is equal to 141.42, tau is equal to 42, and r is equal to 25. Now find the value of w. This quantity get divided to the value of torque, and we will get value of w. which is equal to 6.94 mm, and we will write here in a roundup 7 mm. The width is equal to 7 mm, and write all the quantity. .94 mm and round up 7 mm. Now we find the value of keys, that is thickness, length and width, and this question is asked in summer 15 winter 18 for 4 marks. In similar way you can find different question also. Thank you.